Hi everybody. This is a mini video about density. So what is density? We denote it as D, and some books might show Greek letter rho. Density equals mass divided by volume, which means mass per unit volume. So what you have to know is how to use this formula to do the calculations, how to measure the density, or when the information is given, how to calculate the density. Because this is a mini video, I'm just going to be talking about the application and only the important information. All right, so if I write density as mass per volume, that's one form of the formula. Another form is I can write just finding mass equals density times volume. Or if it is volume, you get it as mass divided by density. So these are the three forms I want you to remember. You don't have to remember if you can derive these or rearrange these equations, but otherwise you have to remember it. So M is mass, V means volume, and D means the density. So if you have something in water, you have seen sometimes certain substances float. So the reason they float is because they are less dense than water. So you say you have some water. If you put certain objects, they might float. They might float it at the top, so you know that they are less dense than water. It doesn't have to be water. If it is a liquid, any liquid, and if you put a substance into that, if it floats, that substance is less dense than water. Density is an intrinsic property. That means it is independent of the amount that is present. So let us talk about water. What happens when you put something into water? So the density concept was introduced by Archimedes. The story says that the king asked him, he was the advisor to the king, and he was asked to find a method to determine if the statue of gold of king made by the goldsmith is pure gold, or is it just inside copper and outside gold. So the story says that he didn't know how to do it, and the last day came, and then he was very depressed, and he filled his bathtub to the brim, and then he stepped in, some water spilled out. Then he realized that's called dispersion. So displacement, sorry, that's the displacement. So he realized that that's the way to find out whether something is pure gold or not, or any other substance, because it's an intrinsic property. So then he was naked, he ran down the street yelling, "Eureka, Eureka," which means I found, I found. So that displacement of water gave him the idea. So I'm going to explain here. Now let us see. We have water filled in a beaker, and we'll say the mark is 10 milliliters. So you get a substance, say a metal, and you putting in the weighing scale and get the mass. So you find the mass by putting it on a scale. Then you get the substance and dip it in water, and sometimes it might sink, sometimes it might float partially submerged, or it might float fully submerged. It doesn't matter. So there is some amount of water. As a result, when you put this substance, the water level will go up. We'll say it went up to 15. Then we know the volume that displacement is 5 milliliters, because 15 minus 10. So 15 is the final volume and 10 is the initial volume, and the difference is 5 milliliters. That's the volume. So we know the mass. We say mass was 10 grams. Just making this up. The volume was 15 ml. Then you know the density is 2 grams per milliliter. It's divided. All right. So what type of questions could you get? You might get a question where they give you the mass, they give you the volume, and ask the density. It's easy. You just mass given volume divided by, you get the density. Or they might give you the mass and the density and ask for the volume. So you know the mass, you know the mass, you know the density, then volume. You rearrange this equation, you get it, the volume, right? Or they might ask the mass by giving the density and the volume. Then you rearrange. This is one of those three equations I told you, and volume, you get that. So if they don't give you the mass, they will tell you that it was put on a scale, and the scale showed how many grams, so you know that's the mass. But when it comes to the volume, they might not give you the volume directly. They might tell you the shape of the object. It may be a sphere, or it may be a cylindrical, or a cube. They might give you the shapes of the substances, or the substance you are using, standard shapes, so you can calculate the volume. So for that, you need to know the formula for to calculate the volume. Okay, so that part you have to find, or they might give you that form. The volume of a sphere, volume of a cylinder or cube. All right. So if they give you that, then you can find the volume. Another way to find volume, they might just tell you there's a measuring cylinder and there is some level of water, we'll say 100 milliliters. And when they put the substance, the water level went up to 120. When they give that, you know the final volume is 120 and initial is 100. So the difference is 20 ml. And as a result, you know the volume. All right. So that's how you apply this knowledge to find the density. But let me go a bit more and explain about the density of water. And I will also tell you what happens when you submerge something, but it is fluid mechanics section, but I will just touch upon that. So density of water is given by 1 gram per, underneath, either cubic centimeters. 1 cubic centimeters means 1 milliliters. So you can say like 1 gram milliliter, or we can say 1,000 kilograms per cubic meter, not cubic centimeter. This is milliliter, cubic meter. Okay. So one of the ways of writing is grams per cubic, like that, grams per milliliter, kilograms per cubic meter. All right, it's the same. So those are the density values. But this density value is the maximum at certain points. Okay, so if you draw a graph showing the density, then I write the temperature. The density of water goes like that and then go down. So the maximum value comes normally here, the maximum density of water. Density max for water is at 4 degrees centigrade. That is the anomaly. What it means is, if you are cooling down water, when you're cooling down, when you cool down water, what happens? normal substances contract. So it reduces the volume. So now again, density equals mass divided by volume. Volume is the denominator. If I increase this value underneath this line, my result is going to be small. So for an example, if I have 10 and initial volume was 2, then 10 divided by 2, I get 5 as the density. But if I increase this volume 5, then you can see density has gone down. So when you cool down, what happens? The volume decreases because they get to the atoms in a substance get closer to each other. Okay, so the volume goes down. So the opposite of this happens. Mass, the volume goes down, so the density goes up. Okay, so when you cool down, normally, if you think about the phases, vapor, liquid, then solid. So solid is always denser. So if you put a solid in a liquid, the solid sinks. Okay, but when it comes to water, that density increases, as we said, because the volume is reducing. So if you have water, liquid, and then as I am cooling, the water molecules come together. And if you haven't studied, you will learn that water molecules has hydrogen bonding, H bonding. Okay, that H bonding comes because of the partial charges in this oxygen, this positive and that positive. So another oxygen nearby will form this bond, which we call hydrogen bonding. Okay, we learn that when you learn about bonding. So for this density, the reason after 4 degrees, what happens though? Up to 4 degrees centigrades, when you cool down, the volume shrinks. But after that, after 4 degrees centigrade, these hydrogen bonds, because of that, they become crystalline. They become a crystalline structure, a hexagonal shape. Just remember that, because now there are other bonds here, so you cannot press it and reduce the volume beyond a certain point. Okay, so this hydrogen bond also has some energy that helps it to arrange into this structure. Therefore, the volume starts going up. Same mass, here same mass, volume starts going up. As a result, the density is going down. So ice, when it comes to ice, okay, so it is 0 degrees or below. That's the temperature of ice, solid ice. So that's why ice floats, because on water, because it is less dense. So after 4 degrees, the density is less. As a result, ice floats on water. So that's a winter time. It helps because if there's a pond, the ice is on the top. So underneath there is water. So fish and other plants could grow and survive. All right. Now I want to just tell you another information that would be helpful about buoyancy. So when I put some substance into this liquid, the reason it goes down is because of the weight, which is a force, which is mass times gravity. Okay. To compensate to that, there is an upward force. Force exerted by the liquid. That's called buoyancy. And something is buoyant, that means it's floating. There's a force. So upward force. So this upward force, for density, you don't need to know that, but for this fluid mechanism, but for the completion's sake, I want to tell you. So the force exerted, this buoyant force, is given by the density of the liquid or the fluid and the gravity and the volume of the amount of thing displaced. Okay, I told you that when Archimedes put his foot, some water displacement happened. So that's so that force, that buoyant force, is more than the downward force here. So this downward force is a different color. So this weight force, if the upward force is higher, if this downward force, which is the weight, is lower than the buoyant force, it floats. Okay, the floating could be partially or completely. So when it's the liquid, it could be partially, means whatever the ratio, or it could be fully submerged, but it's floating. If it goes and hits the bottom, sinks, then it is a lot higher, the weight, then we can't check the weight, we can get the volume, that's all. But when you put this one, if it is floating half or full, submerged completely or partially submerged, you can get the volume, right? Volume that is here. All right. So if the object is denser than the fluid, it sinks, because the weight is more this time, more than the buoyant force, so it sinks. Any of these cases, it could be fully or partially submerged. Okay. Now, if the weight is exactly matching that, it floats, it stabilizes it. It is not partially submerged at the level of water level. Okay. So now the mass of the liquid that is displaced is equal to the weight, the mass of the displaced fluid is equal to the mass of the object. So remember, so when that displacement happens, the mass of the displaced liquid or fluid is equal to the mass of the object. Okay, so what I wrote here, that is the Archimedes principle. But if so, you have to understand, if the object sinks, the displaced liquid mass, draw it again and say, if the object sinks here, the displaced liquid, because it originally somewhere here, then it has gone up a bit, that mass is, the liquid mass is less than the mass of the object. But if the this object is floats like this or like that, fully submerged or partially, that liquid mass of the liquid is equal to the mass of the object. Mass of the liquid is mass of the displaced liquid. Yeah, just remember. Partially submerged or fully submerged, whatever it is. That's all. Okay. All right. So there's I want to tell you about the specific gravity. So the specific gravity means the difference between the densities. Okay. So let me draw it here. So specific gravity means it's the ratio between the densities, two densities. Okay. So if I say specific gravity is given by the density of the object, the density of the liquid, say in this case water, I'll just put liquid, that's what. So it could be d or rho or whatever that. So density of the object divided by density of the liquid, that is called specific gravity. Okay, so specific gravity, this variation tells us if something is floating, what ratio is under the water and what ratio is above the water is given by this ratio here. So just remember, specific gravity is the density of the object divided by the density of the liquid. If it happens to be a water, then density of the water is here. So if the specific gravity is more than 1, when the ratio given more than 1 means this has a higher number. Okay, that means density of the object is higher than the density of the liquid or water, because you can, it's obvious, because you are dividing the density of object by the density of liquid. Okay, so when you divide by this value, if this is a smaller value, you get higher. But if the specific gravity is less than 1, then we can say density of liquid is higher. That means it's going to float. Okay, so that means we get a number that is less than 1 and it gives us a ratio. Okay, so if the specific gravity is, we'll say less than 1, we'll say 0.6 as a percentage, that means 60%, which means the object has 60% of its volume submerged in water. So whenever you get a value smaller than 1, you know the liquid density is higher. So the object is going to float, could float like that. 60%, 0.6 would be 0.6 or 60% is submerged under the water. So this specific gravity ratio could be used to determine what volume is underwater. All right, that's all I want you to know, but I have discussed a bit more than what you need to know for the density, because I have combined the fluid mechanics and touched upon specific gravity, and then I have also touched upon the buoyant force. But mainly you need to be able to know how to calculate the density, or find the mass if the density and volume given, or find the volume if the density and find the mass if the density and the volume given. Okay, or whatever the combinations of that equation. And if they are standard shapes, then you need to know the formula to find the volume. Otherwise, they will say that they dropped it in the liquid and then there was a displacement. That amount is the volume that you need to use for this equation to calculate the density. All right, everybody, I hope you enjoyed this mini video.